What's up, people? Hey, we're on page 424, 425 in our workbooks. So here we go. 8-2, we're about to learn some good stuff. Volume. Take it away. Have your calculator ready.
How is the volume of a cylinder related to the volume of a prism? Think about this question during the lesson. Jenna and Ricardo want to buy a tank large enough for 25 zebrafish.
That's a lot of
They
fish.
figured out that a tank with enough room for their fish needs to have a volume of at least 2,310 cubic inches.
How much stuff can
The
hold?
tank they're considering is 48 inches tall
Okay.
and has a diameter of 24 inches.
We don't like
How
diameters.
can Jenna and Ricardo determine whether the cylindrical tank can hold the zebrafish? Remember, volume is the measure of the amount of space inside a solid figure. You can find a volume by filling the solid with unit cubes.
Of course you can.
As you did to find the volume of a prism, fill the base of the cylinder with one layer of unit cubes, and then you could stack layers until you fill the cylinder. Will filling the tank with unit cubes provide an exact measurement of the volume? Select your answer.
Oh, of course not, people.
You cannot count the cubes because some are incomplete.
They're not all whole cubes, guys.
However, you can still use the
Okay.
volume formula. Volume equals the area of the base times the height. Use the formula to find the volume of the cylinder. It's the same formula you use to find the volume of a prism. In this case, the base of a cylinder is a circle. So the area of the base,
Area of the base.
equals pi times
Pi
r
r
squared.
Multiply by the
Use
height.
3.14 for pi.
Okay.
The diameter of the base is 24 inches, so the radius is 12 inches, and the height is 48 inches. You can use a calculator to find the approximate volume. Remember, Jenna and Ricardo's fish need a tank with a volume of 2,310 cubic inches. Is the tank large enough?
What do you guys think? Tank large enough?
I don't know.
Yes.
What do we need to do?
Its volume is greater
plenty.
than 2,310
Plenty.
cubic
It's
inches.
almost 10 times
The
bigger.
cylindrical tank is large enough
Special
for
guest.
25 zebrafish. Actually, maybe it's too large.
Only 25 zebrafish. Okay,
Say hi, Jelly Rose.
Hello.
that was Jilly.
Now you know how to calculate the volume of
Yeah.
a cylinder.
Well, maybe we know.
It's the
Maybe
same
we.
reasoning you used before to find the volume of a prism.
That's right. Okay, so guys, when they say area of the base, you have to understand that the base is a
Circle.
circle. And so
Circle.
the area of the base we've done before. Pi times the radius squared. Okay? So that's what they're using here for the letter B. That's fine. Okay? It's telling us in this case, hey, the area of the base, right? Or in other words, this area here, right? They're giving us that amount. They said it's 78.5 cubic inches. What's the volume? Well, we're going to take the area of the base, that's 78.5. We're going to multiply it by the height. How tall is that cylinder? It's 11 inches. That's right. To find the volume, guys, all we got to do is multiply those two numbers together. I would ask Jilly what 78.5 times 11 is. She could probably do that. 863.5. Again, we are in cubic inches. Whoa, that's got to be a 3. It's a good looking 3. Okay? There you go. Volume. Guys, volume is always to the power of 3. Good deal? Awesome. Example 1 in the books. Example 2, let's see what we get here. Probably more fun.
Apple juice.
My second favorite juice.
The volume of the apple juice can is 300 milliliters, which is equal to 300 cubic centimeters.
Awesome.
What is the radius of the can? Use 3 and 1400ths for pi, and round your answer to the nearest tenth.
Okay. So guys, 8-2, all about these shapes right here that we call cylinders. Okay? So what does the question want to know? What is the radius of the can? Well, they've given me how much volume the can has in it. They've given me how tall the can is. It wants to know what is the radius, right? What is that dimension from the outer edge to the center of the can? I don't know.
Let's work backwards.
Yes. So guys, this is a working backwards one. This is where we use our formula and then we solve an equation for the missing variable. Okay? So here's what they've done. Again, volume equals area of the base times the height. The area of the base, pi, times the radius squared. Okay? They told us to use 3.14 for pi. We don't know the radius, do we? But we do know the height. We do know that apple juice can is 14 centimeters tall. So where did this 43.96 number come from? Well, remember, it came from 14 times 3.14. Then solve this equation. This is lesson 1-6? 1-7. Solve this equation. Step 1, divide by 43.96. That's how they came up with that 6.82 number. And again, we should be good here, right? 6.82 equals r squared. Just like, could be equal to c squared. Could be equal to b squared. Take the square root, folks. Okay? There we go. 2.6 is how they came up with our radius there. So again, working backwards. Use your formula, plug in what you know, and solve that equation. Okay?
Safety barrels are used on some highways
Safety
to
barrels.
cushion cars on impact. If
All
a city
highways.
manager approves the purchase of 15 cubic meters of sand, how many
Ooh.
barrels can be filled with sand? Use 3 and 1400ths for pi.
Lot going on here. Let's just think of, so imagine guys, we had a classroom full of these barrels, okay? And we had 15 cubic meters. That is a lot of sand. How many barrels could we fill, right? So, well, I guess we need to figure out how much sand would just one of these barrels take. You know what I mean? And then like if one barrel took 1 cubic meter of sand, and we have 15 cubic meters, then we know we could take, 15 divided by 1. All right, we could fill up 15 barrels. That's what we're trying to do here, okay? So they've given us some dimensions. Hey, the diameter of a barrel is 0.9 meters. The height is 1.2 meters, all right? What are we going to do here, right? So volume of a cylinder
Always is
the area of the base
That's
times the height. Okay? The base is a circle. They're absolutely right. So if you want to say the base is equal to pi times what, guys? The radius squared times the height. Okay? So here, we should probably make this a volume. I'm assuming that's what they want here.
Yep.
Let's make that volume. Let's make this the volume. So the volume here is equal to pi times, again, still the radius squared. Wait, we have numbers here. Let's put some numbers in, guys. What's our radius? Radius. Got to use that 0.9 number, right? No. No, guys. 0.45 is your radius. What was your height? That was our 1.2. Okay? So there you go. Once we do that, that will give me the volume. Okay? And then I think we're home free from there.
home free.
At least I hope that we are. Okay? So they're going to do that. They're going to actually calculate this for us now. Okay? Again, this is what we had just a second ago. So that means the volume of one of these barrels is 0.76302 cubic meters. That's how much sand it would hold. That's how much air it would hold. That's how much water it would hold, right? It's just volume. It's all the same thing. So if we have 15 cubic meters of sand, right, and I know each one holds that many, there we go. So we can fill almost 20, right? Almost 20 of those safety barrels. Congratulations.
So we have enough for 15 then.
Oh, yeah.
Oh, that's great.
Okay. All right, here we go. Lynn is building a cylindrical planter with a base of 15 inches. She has 5,000 cubic inches of soil to fill in her planter. What is the height of the largest planter she could build? Interesting. Use 3.14 for pi and round to the nearest inch. Okay. Draw your best cylinder. There's mine.
Your best.
Okay. Plug in what we know, right? We have a base diameter of 15 inches. So in other words, this dimension down here is 15 inches. okay? She has 5,000 cubic inches of soil. So like she could fill up a planter that was 5,000 cubic inches, or that's what the volume could be, okay? So I'll say the volume that she has is 5,000 cubic inches. What is the height, right? I don't know, right? I would like to know the height that we could use, okay? So write out our formula. So the volume of a cylinder, you're going to get tired of writing this out. Again, the book says base times height, right? We know the base is a circle, pi times the radius squared times the height. Okay? We should have 1, 2, 3, 4. So our formula has 4 variables. We got to plug in 3 of them with numbers, okay? We don't know the h, that's the height. That means I'm going to know the first 3. She has 5,000 cubic inches of soil. Pi, what number should I use for pi? Well, it says use 3.14. What number should we use for the radius? Be careful here. I would say 15, and I would be wrong, right? Our radius is 7.5. Okay? Multiply that by the height. Okay. So let's figure out what number this turns into here on the right-hand side. Sorry, you know I love me some lines when we're solving equations. Figure out what number this turns into. Everybody go. Go. It's a race. See who can get there first. Not really. We're trying to get the right number, folks. Just remember that. That will not give me the right number because I missed a 2 in there. Okay, I got 176.625. Hopefully you guys got that as well. 176.625 times the height. Okay, this is a one-step equation. You solved these in 7th grade. We've solved them all year long when we're solving our equations. Divide by this number, right? So we're going to divide 5,000 by 176.625. 5,000 divided by that 176. I do not like Mr. Knoll's calculator. You know why, folks? Because the 1 and the 2 don't always go. Okay, so I get a height of about, rounded to the nearest inch. Okay, so guys, I get 28.308. Whole bunch of other stuff. Rounded to the nearest inch. What is our height here? 28 inches. Okay, rounded to the nearest nth, 28 inches. So guys, there you go. There's 8-2. So we should be ready for key concepts. I believe Mr. Knoll will treat you to some good stuff there, and I'll catch you guys.